Ever wondered why understanding numerical distributions is crucial in statistics? It's because they provide a snapshot of data, offering valuable insights that help us make informed decisions. They reveal patterns, trends, and outliers that might otherwise go unnoticed. Over the next few minutes, we'll be exploring some key plots used to visualize these distributions. Dot plots, stem and leaf plots, and histograms. Each has its unique strengths and applications. So let's get straight into the fascinating world of data representation with our first plot, the dot plot. Dot plots are simple yet powerful. They provide a visual display of data, making interpretation easier. Now let's delve into what dot plots are. Picture a number line, with each value in a data set represented as a dot above that value on the line. That's the essence of a dot plot. It's a simple tool, but it can tell you a lot about your data. Take this scenario, for instance. You're a student and want to collect data about how many siblings each of your classmates have. You could use a dot plot to represent how many students have a certain number of siblings. Each dot would represent how many siblings a student had. Now you might ask, when should I use a dot plot? Well, dot plots are best suited for small data sets. They allow you to see each individual data point, which can be crucial in identifying patterns or outliers. If you have a lot of data, a dot plot might become cluttered and difficult to interpret. In that case, you might want to consider a different kind of plot. And what kind of data is suitable for a dot plot? Numeric data is the key. Dot plots can handle both discrete and continuous data, making them quite versatile, but discrete is usually best. Remember, dot plots work best for small data sets and help to identify patterns quickly. So, the next time you're looking at a small set of numbers, consider using a dot plot to make sense of it all. Stem and leaf plots are a little more complex, but they offer a detailed view of your data. Let's dive into the world of stem and leaf plots. These plots are a bit like bar charts turned on their side, but with more detail. The stem represents the leading digit or digits, and the leaf represents the trailing digits. For example, if we have the number 75, 7 would be our stem, and 5 would be our leaf. Now let's imagine a situation. Suppose we have a set of scores from a class test, and we want to visualize how the students performed. A stem and leaf plot would be perfect for this. We'd have the tens digit as our stem, and the units digit as our leaf. In this way, we can see each individual score, and yet still get a good visual representation of the overall distribution of scores. But that's not all. We also have something called a back-to-back stem and leaf plot. This is a comparative tool that lets us view two sets of data on either side of the stem. Let's say we want to compare the test scores of two different classes. We'd place one set of scores as leaves on the left of the stem and the other set on the right. By doing this, we can easily compare the distribution of scores between the two classes. So, when should we use these plots? Well, stem and leaf plots are great for medium-sized data sets. They're not the best for very large data sets because they can become a bit unwieldy. But for medium-sized data sets, these plots are perfect. They give us a clear view of the data distribution, allow us to see individual values, and make it easy to compare different sets of data. In summary, stem and leaf plots, including back-to-back stem and leaf plots, are powerful tools in the world of statistics. They provide a detailed yet clear view of data distributions. So the next time you're faced with a medium-sized data set, remember the stem and leaf plot. Stem and leaf plots are perfect for medium-sized data sets and give a clear view of data distribution. Histograms, the go-to for larger data sets. They provide a snapshot of data distribution over a range. So, what exactly are histograms? Imagine a city skyline, where each skyscraper represents a range of data from one number to another number, and the height of the building illustrates the frequency or amount of data within that range. That's the essence of a histogram. Histograms are graphical representations that use rectangular bars or bins, groups in other words, to show the frequency of numerical data within certain intervals or ranges. Each bin, sometimes also called a bucket, represents a range of values. For example, from the ages 30 to 35, and the height of the bin corresponds to the frequency or amount of data points within that range. Let's consider a practical example to illustrate this. Suppose we have a data set comprising the ages of all employees in a large corporation. The data ranges from 20 to 65 years. A histogram of this data might have bins representing 5-year age intervals. So the first bin might include all employees aged between 20 and 24. The next, those aged 25 to 29, and so on. The height of each bin then indicates how many employees fall into each age bracket. Histograms are particularly useful when dealing with large data sets, as they help us to visualize the distribution of the data. They can show us where most of the data falls, whether there are any outliers, and if the data is symmetric or skewed. However, it's important to note that while histograms are great for displaying numerical data, they're not suitable for all types of data. They're best used for continuous data, where the values can take any value within a certain range. For instance, in our previous example, age is a continuous variable because it can be any value between 20 and 65. On the other hand, histograms aren't as effective for categorical data. Histograms are ideal for large data sets and help to understand the frequency of data over intervals. And that, in essence, is what histograms are all about. We've journeyed through dot plots, stem and leaf plots, and histograms, each unique, each powerful. Let's take a moment to revisit the key points. Dot plots, with their simplicity, are ideal for small data sets, providing a clear view of each individual value. Stem and leaf plots, on the other hand, are great for medium-sized data sets. They allow us to see the distribution and shape of the data while keeping the original data values. Lastly, histograms, perfect for large data sets, give us a snapshot of the data distribution by grouping the data into bins, buckets, intervals, or groups of small ranges. Remember, the choice which to use depends on the size and type of your data. So whether it's displaying test scores or analyzing population trends, selecting the right plot can make a world of difference in understanding your data. Mastering these plots means taking a big step towards understanding and interpreting data. So keep practicing and let your data tell the story.